Hello friends, welcome back to our channel. So in today's session, we'll discuss about exception handling in Python. So before going to the concept, let me explain you about the different kinds of errors. So there are mainly three types of errors, right? So the first one is syntax error, the syntax error or the compiler error. These are also called as compiler error because these errors will be identified by the compiler itself, right? So this can be easily identified and this can be solved by the user. And the second type of error means it's a logical error. So these are very difficult to identify because these errors are written by the user itself. The user will write these logical errors. So that means error in logic. So these are very difficult to find out, and uh, you have to trace each and every instruction in order to identify the logical errors. And the third category is there will be no logical error and there will be no syntax error, but during the execution there might be a chance of getting an error that is called runtime error. Runtime error. This is done during the runtime, during execution of a program. So we'll get the error, and here this syntax error will be displayed on the screen. And similarly, these the third category, runtime errors are also displayed on screen, right? And these logical errors are not displayed, okay, they are not visible. So we needed to identify, right? Let me show you the example for syntax, logical and runtime. And usually these runtime errors, that means during the execution, if any event occurs which disturbs the normal execution, that is called as a runtime error, or we can also call it as a exception. So once the exception is raised, automatically the program will be terminated, right? So let me explain you about all these three errors. See, for example, so if you want to identify for uh, I in range of 10, right, and give here print I, so this is nothing but the syntax error, because after the for we need to give the indentation because for is a block. See, this is a syntax error, so these errors will be identified by the user itself, sorry, by the compiler. So it would be very easy to identify and it will be very easy to clear. And the second type is a logical error. If you want to write a logic for addition of two numbers, if I take two values 10 a comma b is equal to 10 comma 20, and if I write the logic c is equal to a minus b and print c, right? So my intention is I need to write a program to perform the addition of two values. So in a mistake I have written some a minus b. So what we'll get, will not get any error in this case, but this is a logical error. So that means the output will be different from the expected output. So here the logic is different, logic is wrong. So these logical errors will be written by the user itself. Okay, there will be no error will not be displayed here. Coming to the runtime error, so if you take some a is equal to int of input and b is equal to int of input, and if you want to perform the a by b, see, if I give a with the 10 and b with the 2, we'll get a normal result, there is no errors, right? So if I give here 10 and 0, so the denominator should not be 0 in the division, right? So here we are giving the 0, then it will return an error called a zero division error during the runtime, during the execution of statements. So for some sort of inputs we may get these exceptions. So if you get these exceptions, automatically the program will be terminated, right? So the exception means which disturbs the normal flow of execution, right? So if our program had some four lines of statements, so s1, s2, s3 and s4, so four statements. If an exception is raised at statement 2, then the 3 and 4 statements will not be get executed because the program terminates here. the program will be terminated. The program will be terminated, right? Terminated and quits. So what we have to do? So we have to handle these exceptions. Whenever the exception is raised, we need to handle the exception. So how to handle this exception? So we can handle this exception by using except block. Except block. So in order to handle the exceptions, we are going to use the four keywords. Sorry. So in the exception handling in Python, we are going to use the four blocks. One is try block, except block, else block, finally block. Right. So coming to the else and finally or the optional blocks. These are optional. So we may write or we may not write. Then try. In this try, we need to write the instructions. We need to write all the instructions from which we are expecting the exceptions. We are expecting the exceptions, right? So all those statements should be written in try. So in the try only we'll get the exceptions. In the try, the statements which we have written in the try are the instructions which we are going to expect the exceptions. And if the exception is occurred, this except block will be executed. So exceptions which are raised in try block will be handled by the except block, by this block. Okay, so only the exceptions raised in the try block instructions will be handled by this except block. That means whenever the instructions is having the exception, this except block will be get executed. This except block will be get executed. So if there are no exceptions, then else block will be get executed. No exceptions. If there are no exceptions, else block will be get executed. And irrespective of the thing, always the finally block will be get executed. That means if the exception is raised or exception is not raised, the finally block will be get executed. So among these two, except and else, only one block will be get executed. If there is any exception in the instructions written in try, then except will be executed. And if there is no exceptions raised from the try block, else part will be executed. Right. So I will show you a small example and we'll wind up, and in the further sessions we'll see how to handle multiple exceptions and all these things. Now let us write this one. So this same thing we'll discuss the zero division error. Consider this zero division error. So I will write a request message. So enter value for A, and here we'll write enter value for B. Now you can see print A by B. So I can expect the exception in this statement, because if the denominator is 0, then automatically we'll get the exception. So I will write try block here, try, and instead of this one I will write A by B and print C. So if there is no exception, if there is an exception raised here, that should be handled by the except block. So I'm writing some except block, and here I will write print exception raised, right? And else, if there is no exception, I will print no exception. And always the finally block will be get executed. So finally print program ends, right? Now give a value and B value. If I give a B value as 2, there will be no error. Okay, there will be no error. See, A is equal to 10 and B is equal to 2. So try block C is equal to 10 divided by 2. There is no exception here. So automatically C value will be printed and except block will not be get executed because there is no exception. So else part will be executed. So else part no exception and program ends. If you give the denominator as 0 now, if you give the denominator as 0, so you can see the next statement will not be get executed. So print C is not executed because the exception is raised at this particular statement. So just now we have discussed that if the exception is raised, automatically whatever the statements written after that particular after that particular instruction will not be get executed, right? The program will be terminated. Now here the exception is raised, automatically the control will move to the except block and this will be executed. So we got the message as exception raised and always the finally will be get executed, so program ends. So if there is an exception, else part will not be get executed, else part will not be get executed, right? So this is how we can handle the exceptions. So in today's session, we'll discuss about how to handle the single exceptions in Python programming. So in the previous session, we have seen what is an exception and how the exceptions can be handled. So in the exception handling, we are mainly focusing on the 4 keywords, that is try, except, else and finally. So we have to write the instructions from which we are expecting the exceptions in the try block, and whatever the exception raised in the try block will be handled in the except block. And if there are no exceptions raised from the try block, then the else block will be get executed. And irrespective of the exception occurrence, that means whether the exception is occurred or not occurred, so the finally block will be get executed. So this we have discussed in the previous session. Now we'll see how to handle the single exceptions. So in Python, generally the complete errors will be considered as exceptions. And here there is an exception which is nothing but a base class for all the exceptions, all other exceptions, right? So this is a base class. Exception is the base class for all the exceptions, and these are the normally errors we'll get in the Python programming. Very few errors, there will be a lot of errors, and I have already explained about all these things in the previous session. I will post the link in the description, so just you go through that to get aware about all these errors, when we'll get the error. So if the error is occurred, then how to handle it? So that can be done in the exception handling, and that should be written in the except block. So we'll execute the program and we'll see. So in this session, we'll see the zero division error as well as the index error. We'll check these two. So let us take the two inputs. A is equal to int of input enter value for A, and similarly take another input. So int of input enter value for B, right? Now we need to apply the division operation. We need to apply the division operation, and also we'll have a list. L is equal to some 10, 20, 30, 40, 50. So I will be having some list. Now we need to apply the division operation and we'll access one element from the list. So we can get the exception for the division operation if the denominator is 0. And we can get the list of index error if we are accessing the index which is out of range. So we'll write both in the try block, because we need to write the instructions in the try block such that we may expect the exceptions. So first one, C is equal to A divided by B and print C. And similarly we'll also print L of, so here we can see 0, 1, 2, 3, 4. 4 is the last index. So I'll access 5th index so that we'll get an exception, right? And except. So what we have to do here, we need to handle the exception. So as we have discussed just now, exception is the base class, right? So we need to use the exception here. So first of all, let us print this here, exception raised. Simply we can say exception raised, right? So I'll execute this one. Let us give the value 10, and if you give the denominator as 0, we'll get exception raised. And this statement will not be get executed, the third statement, because here itself we got the exception. And if you execute the same thing 10 and 2, there will be no exception like zero division error, because the denominator is not 0. But it will print C value, and whenever the control executes the third statement in the try block, then the exception will be raised, because 5 is the index which is not in the range. So then, so if you execute the same thing, so just wait. If you execute the same thing, 10 and 2, so 5 is printed, but when coming to this here, the exception is raised, and immediately that exception will be handled by the except block. That means it will, the control move to the except block and it will be get executed. So if you want to know which type of exception is occurred, then simply use the base class exception as E. So whenever the exception is raised, that particular exception will be stored under E. So simply if you print E, we'll get the exception, what exception is raised in the instructions. For example, if you execute the same code, so if you give 10 and denominator 0, see, we got the result as division by 0. So this is division by 0 exception occurred in the first line. Immediately that will be copied to E. The division by 0 is copied to E, and if you print E, automatically we'll get the exception name, which exception has been occurred. And execute the same thing. If you go with the 10 and 2, that here the denominator is not equal to 0, there is no exception, there is no zero division error, but when executing the third line, we'll get index out of range. So execute this one. Execute this one, see, list index out of range. So 5 was printed, the output was printed, but whenever you execute the third instruction, we'll get a list index out of range. So that exception will be copied to E, right? So this is another way. And also we can give some default values and we can execute the except block. That means whenever the exception is raised, immediately the control will execute the except block. So whatever the instructions we are giving in the except block, that will be get executed. Now here observe, so I am giving here, if it is a zero division error, I'll give the default value as 1. So B is a denominator, so I will give the default value as 1 and I will execute the same instructions A by B and print C. Okay, and after that just go with the access of 4, which is valid 0, 1, 2, 3, 4 for last element. So execute this one. If you give 10 and 0, now will not get any exception, right? So that means if you will get the exception, but that exception will be handled by the except block. So if there is an exception occurred, immediately the except block will be executed. Now B is equal to 1 and C is equal to 10 by 1 will be executed. You observe, just see, we got a 10 because whenever the exception is raised, so here you can simply write down here, so exception raised, so using default value for denominator, right? So you can observe this one. See, if you give 10 and 0, it's a zero division error, so immediately the except block will be executed. So exception raised and using default value for the denominator will be displayed, and all these instructions will be get executed. So you can observe here, so exception raised and using default value for denominator, so B is 1 and C is equal to A by B and print C, right? So hope you understood this one. So if you want to if you want to handle a particular exception, you can also give the exception name here. So you need to remember these exception names. You need to remember these exception names so that whenever the exception is occurred, then that particular block will be get executed. So here we can simply pass zero division error. So only the zero division error will be occurred, right? See, if you execute this one, so 10 and 0, so automatically this will be executed. And if you access, see, I'll give here index error, right? So if I execute this one, sorry, okay, 10 and 0, see, the zero division error was not executed, right? Was not handled, because we are writing this except block only to handle the index error. So we can mention the exception name so that that particular exception will only be handled by this except block, right? So here we are getting the zero division error, but we are writing the except block for handling the index error. So that's why it will handle only the index error. So if you execute this one and see, if you go with the 10 and 2, there is no 0 by division. So automatically the index error will be executed and all the instructions will be got executed, right? So if you write here zero division error, so if you execute and there is no zero division error, okay, there is no zero division error, then the index error in the third instruction, there is an index error which cannot be handled by the except block because we are writing only the zero division error. So this except block can be used to handle only the zero division error. So these many ways we can handle the single exceptions. So we can simply implement the except block. So whatever the instructions you are writing in the except block, that instructions will be get executed, right? So in the except block also we can pass the exception name so that only that particular exception will be handled by the except block, and we can pass the base class of exception as variable so that if the exception is raised, that exception will be copied to that variable name, and if you print that name, print that variable, we'll get the name of the exception raised, right? So hope you understood this one, handling the single exception. So multiple exceptions. So in the previous session we have discussed about the different blocks. In the try we are supposed to write the instructions from which we are expecting the exception, and whatever the exceptions raised in the try block, that will be handled by the except block. And here in the previous session we have discussed about how to handle the single exception. So directly we can write the instructions what to be executed if the exception is raised, or so whatever the exception it may be. And you can also specify the exception name. You can also specify the exception name so that if that particular exception is raised, this except block will be get executed. Now, how to handle these multiple exceptions? So these multiple exceptions can be written in two ways. Okay, implemented in two ways. That means writing multiple excepts. So writing multiple except blocks, right? So here except exception name, and again you can write one more except with another exception name, and similarly you can write again except with the exception name, right, and so on. So this is one way how to handle the exceptions. If you are writing here in the try block, if you are writing the instructions, and if in these instructions if you got any exception, that particular block will be executed. So here we are specifying the exception name. So based upon the exception raised in the statements written in try, that particular block will be get executed, right? Otherwise we can use a single except with a multiple exception names. So by using a single except block also we can handle the exception, single except block, right? So you can handle these exceptions in different ways. So multiple exceptions can be handled by using multiple except blocks, single except block. So how can we handle the multiple exceptions using single except block? So simply write the try and write down the instructions need to be get executed and where you are expecting the exception, and write down here the except, give the exception name 1, comma, exception name 2, comma, and so on. So you can specify the multiple exception names in a parenthesis for the except block. So in this way also you can handle the multiple exceptions by using a single except block. Right? So these are the two different ways we can handle the multiple exceptions. One is by using the single except block. So specify the exception names, a comma separated exception names in the parenthesis to the except block, or simply use a different except blocks with a exception name, right? So these are the two different ways we can handle the exception. So now I will demonstrate with a small example how can we handle the exceptions, multiple exceptions using single except block and multiple except block. So let's move on to the system so that I will explain you everything. So if you are still having any doubts, your doubts will be clarified after watching the execution.
Let's move on to the system.
Hello friends. So just now we have seen the theoretical part of handling multiple exceptions in Python, and now I will show you with a small example. So let us take two different errors. Okay, that means exceptions. One is a zero division error and another one is an index error. So first let us write the try block, and here I will give the two exceptions. One is a division by zero and another one is a index error. So first let me take the two values. So int of input enter value of a, and b is equal to int of input enter value, sorry, and enter value of b, right? Now also take the list. L is equal to 10, 20, 30, 40, 50. 5 elements. In the try block, I am supposed to give C is equal to A divided by, and print L of C 0, 1, 2, 3, 4. I'll give 5. So we can expect two different exceptions. One is the zero division error and another one is the index error. Now we can write the except block, and here you need to implement the different except blocks, right? So I will give two different except blocks, one to handle the zero division error, another to handle the index error. So I'll give this one, so zero division error. So here you can print divide by zero exception raised. So whenever the zero division by zero exception is raised, automatically this except block will be get executed, and I will write one more except to handle the index error, right? So here I will print index is out of range. Okay, index is out of range. Now we can write a one more except, so which can handle any other exception, right? Any other exception, simply you can go with this one, print exception raised. See, if I execute this one, it will prompt for A and B. I'll give 10 and 2. So there will be no zero division error. There will be no zero division error. So automatically coming to this one, list of index 5. So index 5 is not available. So we can get the index error. So automatically except block will be get executed. See, if I execute this, index is out of range. So except this except block is executed. And if you give this input 0 divided by 0, automatically the zero division error has been occurred and this particular except block will be executed. That means even though you are writing in the multiple except blocks, only one except block will be executed. That is also the first exception raised in the instructions written in the try. So whatever the exception raised first, that particular block will be get executed. See, if I write here some uh, d is equal to, I will write some Python plus 20. So I am supposed to add a string with an integer, so directly we'll get the type error. Type error. Okay, type error exception. So is there any except block written for the type error? No. So here we are having the three except blocks. One is for handling the zero division error, another one is handling for index error, and third one is a generalized except block. That means other than these two errors, if there any error occurred, automatically this except block will be get executed. So now if you give any value, so if you, even though if you given 0, the first exception raised is a type error, so automatically exception raised will be occurred. See, 10 and 0. Sorry, previously I have not executed. So now now you can observe here. See, exception raised. Okay, so previously we have already executed and we have given input, but we have not pressed enter. So then we have modified this one. So that's why once again I am executing this one. So we got this 10 and 0. Even though it is a zero division error, the first line is a type error. The first line is a type error. So automatically this except block will be get executed. So because this the error, the first exception is a type error exception. So we have not written any special except block for the type error. So automatically this except will be get executed, right? And this is one way to handle the multiple exceptions. Other way, we can take a single except block. We can take a single except block specifying a comma separated exceptions. See, index error. See, I have given comma separated exceptions in the parentheses. Now you can observe here, if you execute, so 10 and 0, so exception will be raised. And if you execute 10 and 2, exception is raised because here there is a problem. Now if you trying to access 4, okay, and let us take the string is equal to, let us take the type error. Okay, so we have not written this type error in this exception. So if you give some 10 and 2, so there is no exception, zero division exception is not there. In the second statement L of 4, so fourth index 0 1 2 3 fourth index, there is no exception, so automatically 50 will be displayed. And in the third line we are having the type error, but in the except block we are writing this except block to handle only the zero division error and the index error. So we have not mentioned any type error, so obviously we'll get the error. So just a second. So if you execute this one, so give the 10 and 2, there is no zero division error. So automatically 50 is displayed. There is no exception raised from the second statement. In the third statement, there is an error, that is a type error which is not mentioned in the except block. So obviously we'll get the error here. And if you mention the same thing here, type error, so then the type error is also has been handled, right? So we have to specify a comma separated exceptions, multiple exceptions in a parenthesis in the except block, or else simply give the exceptions here and write down the multiple one more exception which can accept other than these two errors, right? See, type error, or simply just give except or except exception as E, so that whatever the exception is raised, that will be stored in E. So print E. So if you give 10 and 2, there is no zero division error, there is no index error. So we can only concatenate string to each string. So that is nothing but a type error. That's nothing but a type error, right? So if you given like this, string is equal to some d is equal to int of, let us take abc, so which is nothing but we are trying to convert the numerical character strings to integer. This is not possible, so we'll get a value error. So if you write like this and if you execute, there is no zero division error and there is no index error, then so what is this one, exception is raised. Okay, we have given 0, right? So once again I will give 10 and 2, so there is no zero division error. So you can see print E, that means invalid literal for int with base 10 ABC. So we can specify either the exception as E, or we can specify the exception name, or you can simply leave it. You can simply leave without specifying any exception, so that can handle any other exception. Any other exception. So 10 and 2, you'll get exception. So this will be executed. So hope you understood this one. How can we handle the multiple exceptions? So one thing, by specifying all the exception names, the comma separated exception names in the parentheses in the except block. One more thing, we can specify each and every exception with a single except block, I mean individual except block. So if you want to handle 4 exceptions, we can write a 4 except blocks. So even though there are multiple except blocks, only one except block will be get executed based upon the exception raised in the statements written in try. The only one except block will be get executed, right? So hope you understood. So raising the exceptions. So normally in the previous sessions we have discussed about how can we handle the single exception as well as the multiple exceptions. So for that we are writing some try block and except block. So whenever the exception is raised, immediately the except block will be get executed. So if there is any problem with the inputs or with the data, then exception will be automatically raised. But here we can raise the exception. Okay, so mainly we can use this raising exception in order to validate the inputs. Right? So I will tell you the example. Let us take the zero division error which we have seen in the previous session. So C is equal to A divided by B. So we are taking two different inputs, right? So before that, before this expression, we are taking some A is equal to int of input, right? And similarly B is equal to int of input. So we are taking two inputs and directly we are executing the expression. So A divided by B. And whenever the B is 0, then it will automatically raise the exceptions. But now we can use the keyword called raise in order to raise the exception. So based upon the condition, we can raise the exception, right? So before executing this C is equal to A divided by B, we can directly check. So if B is equal to 0, simply use a raise exception. Raise the exception class. So here we need to write the exception class name. Right? So what type of exception we need to raise? So here it is a zero division error. So in place of this exception class name, we need to write it as zero division error. Right? Division error. That means we can validate the inputs. Right? So after taking the input, we can validate. Okay, if the condition fails, automatically, if the condition is true, automatically we can raise the exception. For example, if you are taking marks of a student, so we know that the marks of a student should be greater than 0 and less than 100. So we need to check this condition. So if the input is violating this one, automatically we can raise the exception. So for that purpose, to validate the inputs in our instructions, we can simply use the raise keyword to raise the exceptions. And whatever the exception is raised here, that will be handled in the except block, and remaining content is same. So whatever the exception is raised, that exception will be handled by the except block. So the use of this raise means we can raise the exception. So previously the interpreter will raise the exception, but here we can raise the exception if the given condition is true, right? So let's see a small example demonstrating this raise keyword, right? Let's move on to the interpreter. Hello friends. So just now we have seen the syntax of a raise keyword and what is the purpose of using the raise. So in order to raise the exception by the user, we are going to use the raise keyword, and in order to validate the inputs, we'll use the raise. So I will demonstrate with an example. So let us take the same example, zero division error, which we have considered in the previous session. So first let us read the two variables. So int of input, and here write the request message, enter value for A, and take the second input. So int of input, enter value for B. Right now, previously we have written some try function, and here we have written some expression A divided by B, and we have written some C, and here we are writing some except block, and here we are simply writing the exception, right? So exception raised. So this exception will be automatically raised whenever the exception is occurred. So if it will prompt for the two inputs, I will do 10 and 0. So obviously the denominator is 0. So whenever the control executes this expression, that is C is equal to A divided by B, immediately the exception will be raised, and that exception will be handled by this except block. So you can observe here exception raised. But now, before evaluating the value in the expression, we can validate the inputs. That means if B is equal to 0, immediately we can raise the exception. So raise exception, right? raise the exception. So sorry, if you go 0, automatically the exception will be raised and that exception will be handled by the except block. Now you can also specify the type of exception that can be raised. So here the type of exception is a zero division error. So instead of writing the exception here, we can mention zero division error. So obviously the zero division error will be handled in this particular block. So zero division error. So if you execute this one, zero division error, we'll get this one, right? Exception raised. And here also you can pass the message. So here I will write divided by 0, right? And here you need to pass the variable and you can print this e. That means whatever the message we are sending here, that message will be stored in e, and if you print this e here, so we'll get the same message. So that means we can raise any exception, so without the exception name or with exception name. So if you are raising any exception without name, simply use the exception keyword. So exception class, exception is the base class, right? Exception as exception, and here you need to write like this. So you need to pass the exception as e, so that whatever the exception is raised, that will be stored in e. And if you print this one, sorry, so whatever the input here we are giving, that will be stored in e, right? See, exception is raised. So like this we can raise the exceptions, whatever the exceptions. So mainly the main purpose of using this raise keyword means in order to raise the exception by the user itself, depends upon the inputs. So if we want to consider one more example, and I will close it. So let us take the marks. So you need to read the marks, okay, and print the marks. And see, for marks, I will take the variable marks is equal to int of input enter marks, and we know that the marks should be greater than 0, greater than or equal to 0, and less than or equal to 100. So we need to validate here. So marks less than or equal to 0, or marks greater than or greater than 100. Okay, less than 0 and greater than 100. So if this condition true, then we can raise the marks, raise the exception. We can raise the exception, right? So raise the exception here. Marks should be in between 0 and 100, right? So here we can simply write, sorry, we need to place them in a try block here. Okay, we need to place them in a try block, because whatever the exceptions raised in the try block itself, then those exceptions will only be handled by the except block. So here we can write the except. So except exception as e. So if you print e, automatically the message will be printed here, displayed here. See, if the marks are 120, then marks should be in between 0 and 100. Okay, and here you can simply print marks is equal to marks, right? See, if it is 100, marks is equal to 100, and if marks are -10, the mark should be in between 0 and 100. If marks are 120, marks should be in between 0 and 100. If the marks are 99, the marks will be 99, right? So we can validate the inputs and we can raise the exception, right? So this is the use of the keyword raise. So in today's session, we'll discuss about how can we create the user-defined exceptions in Python programming. So till now, we have seen different exceptions, and all these exceptions are the standard exceptions. So if that particular exception is raised, we have seen how to handle the standard exceptions. Now we'll see how can we create our own exceptions and how can we handle it, right? So let's start the interpreter and I will show you that. And we have discussed in the previous sessions that every exception is a derived class from the exception class. That means all the standard exceptions are derived from the exception class. Similarly, if you want to create the user defined exception, that exception should also be derived class of exception class. See, for example, if you are supposed to enter the marks for a student, we know that the marks of a student should be greater than 0 and less than 100. So the mark should not be less than 0 and greater than 100. So in such cases, the marks, if you give some marks less than 0 or greater than 100, it will be accepted. But if you use the exception, so we can raise the exception if it violates the condition, right? So that type of situations we can create our own exceptions. See, first we need to create an exception, user defined exception, which is derived from the exception class. I will give the exception as invalid data. So invalid data is my exception, so which is derived from exception class, because all the exceptions are the derived from exception class, and simply you can give the empty body, no problem. So now just take the input for marks. Marks is equal to int of input, give the request message, enter marks for student, right? And now I will write down the try block, and in the try block I will write a condition if marks less than 0 or marks greater than 100, so we need to raise the exception. What is the exception here? Raise invalid data, and whenever it was raised, simply use the except block. So except invalid data, and write down the here whatever the statements we need to implement if the exception is raised, that should be done here, that instruction should be written here. So I'll write simply marks should be in between 0 and 100, right? If the exception is raised, automatically this particular message will be displayed. Now I am executing this one, so enter the students for marks, so I'll give 120. So automatically that exception will be raised. That means the invalid data exception will be raised, and the except block will handle this invalid data. So here we are writing the exceptions what to be executed if the exception is raised. And before using this exception, we need to derive this exception from the exception class, right? So if you are raising any other exception, invalid marks, right, and these invalid marks was not derived from the exception, because we have not written any class for this particular invalid marks, so this will not give, this will not be handled by the except block. If you give greater than 120, you can get here a name error, because invalid marks is a name which is not defined, because in our perception, invalid marks is an user defined exception, but interpreter will never treat it as a user defined exception, because it was not derived from the exception. Now if you derive it from the exception, see, invalid marks derived from the exception, right? Now it can be handled, right? It can be handled. So all the user defined exceptions or the standard exceptions should be derived from the exception class. So that you have to remember, and once it was done, automatically that can be raised and that exception can be handled by the except block, right? So hope you understood this one, and if you are having any doubts regarding this user defined exceptions, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.